Okay, today we're doing 3.3, which is just like yesterday, but instead of being prisms, we're doing surface area of pyramids and cones. So the lateral area, again, is the sides of the pyramid. So how many sides depends on the bottom of the pyramid. So because this is a square base, then the pyramid has 4 sides, so there's 4 triangles. You can use these formulas if you want. It's no big deal, but I don't like to do that because it doesn't make as much sense to me. So, but they work. You just have to know what the P and the L stand for, and it's in the definition. Surface area is when we take the lateral sides and then we add the base to it as well. Okay? So, find the lateral area and surface area of a regular pyramid. So these pyramids are all going to be triangles, so you just have to make sure that you know which side is the base and which side is the height of the triangle. So our base is down at the bottom, so we're not going to worry about that just yet, but we're going to do our lateral area, and so we are going to see that this right here is the base of the triangle, which is 6, and this right here is the height, which is 11. And we know this is 6 because it's a regular pyramid, so I'm going to highlight that. And when we say regular pyramid, it means that all the sides are congruent. Okay, so I'm going to write that. We wrote it yesterday too, but okay, so the lateral area is going to be the area of this triangle times 4, because I have 4 of them. So the area of a triangle is 1/2 base, so area, 1/2 the base, which is 6, times the height, which in this case is 11, because they draw that line up. It's perpendicular to the base. And then we are going to take all that, because that's the area of one triangle, and multiply it by 4. So then we plug that into our calculator, boop, 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 and then we get that our lateral area is 132, and our unit is going to be inches squared because it's area, and area is always squared. And then what we have left to do is find the surface area, and so for the surface area, that's going to be the 132 from the sides, but then we also have this lateral area right here, which is a square. So in order to find that, it's going to be 6 times 6, which is 36. So we get the surface area is going to be 168 inches squared. All right. So that seems pretty straightforward. We're moving on to the next one, and we're going to have to be a little bit more careful there. So we get to here, and again, I said the trickiest part of this lesson is going to be able to find your height of your triangle. So the height of the triangle is always this piece right here. Now this triangle on this pyramid actually is regular again, so all 4 sides are the same. But we know right here that this base is 20, but what is the height right there of the triangle? So this is what we have taken out of the pyramid. We have, this is 20, right? And then this, sorry, that's not 20, that's 24. So I'm taking this triangle out right here. So this is 24, and this right here is, well, what is this dimension right here? So I'm going to color code this, so I'm going to erase this. So I, right now, am finding and taking out this triangle, because this triangle right here is going to have the hypotenuse of the side triangle that I actually need. So let me say that again. We don't know the height of this triangle that we're trying to find, right? But we can see this other triangle back here, and if we know the two sides of that triangle, then we can find the height of this one. But you're like, Woken, we only know the 24, we don't know this piece down here. So first of all, let me draw that triangle so it coordinates. To find this triangle right here, if this is coming down from the center and the whole distance is 20, this is going to be half the distance, so this is going to be 10. So how can we find this right here? We can use the Pythagorean theorem. So to find that, to find the height of the one that we actually want, we're going to do a squared plus b squared equals c squared. So remember, a and b are always the sides and c is always the hypotenuse. So c is always the one opposite the right triangle, the right angle. So I'm going to do that, and I get 576 plus 100 equals L squared. So then I get that L squared equals 676, and I square root, and I get L equals plus or minus, what is that going to be in my calculator? Like I could do that in my head. Nice even number, 26. So that right there tells us that this triangle is got a length of 26. Okay, which we need to know because that's the height of the triangle. Remember, we're trying to find the area of one of these outside triangles. We're not trying to find the area of the inside one, but it can definitely help us. Alright, so if we have that, the lateral area is going to be 1/2 the base times the height, and then we're going to multiply it by 4 because we have 4 of them. So the lateral height ends up being 1040, and in this case they're meters squared. Now to find the surface area, we're just going to take the lateral area and add in the area of the base. And that area is just going to be 20 times 20. So when I do that in my calculator, I end up getting that the surface area is 1440 meters squared. So you really have to pay attention to what you're given in your triangle. So up here, this 11 tells us that the height of the side triangle that we're actually trying to find is 11. So that was the intro one. That was pretty straightforward. Then it got a little more complex because then we had to use this inner triangle that they gave us, where from the apex to the base we were given a height, and then we had to know that this was half to be able to use the Pythagorean theorem to find the height. And now we're moving on to the next one. So first thing that I notice about this example is that the base is not rectangular, right? The base is triangular right there. Okay? So because I know this, look at this, let's do our lateral area. Now we are given the actual height of the triangle that we want. We are given that it's 7, and we also know that this base is 4. So to find the lateral area, we're going to go 1/2 the base times the height, and then how many triangles do we have? We have 3. So I'm just going to write this area of one triangle, and then we have 3 triangles. So we punch that into our calculator, and we get that the lateral area is 42 centimeters squared. Woohoo! Okay, now we need to do the surface area. So in order to find the surface area, I'm going to take this right here, this triangle from the base, and I'm going to try and figure out what the height is. So the way that I'm going to do that is that I know that this is 4 centimeters and I know that this is 4 centimeters. Since this is not a right triangle, I don't know for sure what the height is going to be. So here is the height right here. I'm going to drop a perpendicular line so that I can find my height. And because this triangle is part of this prism right here, this pyramid, then I know that that perpendicular had to cut that in half. So I'm going to kind of do this in a different color so you can see. So I'm going to use this piece of the triangle to find the height right there. So the formula is a squared plus b squared equals c squared, and c squared is always the hypotenuse. That's opposite the right angle. So this guy is 4 squared, so it's different from the last one. B squared I'll leave blank, and then the other side, which is this guy, is 2 squared. So I get 4 plus b squared equals 16. B squared equals 12 when I subtract the 4. So then b equals plus or minus square root 12 when I square root. And I'm going to ignore the negative case. Now if you look up here, reading directions carefully, it says round to the nearest tenth. So if you're asking me if you need to rational or simplify that, because that can be simplified, the answer is no, because it's telling us right there that we can go ahead and use our calculator. So the surface area is going to be the 42 from the sides of the triangles, the sides of the pyramids to that we have to add our base area, 1/2 the base, which what is the base of this triangle. So if this is the height, all 3 of these have a base of 4, and then the height is square root 12. So I'll do that in my calculator right here, just so that you guys can see what it would look like for me to punch it in. It would be 42 plus 1/2 times 4 times square root 12. So I'm just using parentheses instead of writing square root 12. Don't you love when you do what I just did and accidentally push clear? There we go. So this gives me that the surface area is 48.9 centimeters squared. Okay, so that one was for all of our triangular pyramids and rectangular pyramids, and now we are going to go on to cones. So we are going to use the formula with cones because it's just easier to use them, in my opinion, and my opinion counts. So if it's not your opinion, it's okay. You can do it without the formula, just like on the ones that we didn't do with the formula, I said that was fine. So the lateral area of a right cone is pi RL. Okay, so the lateral area is the triangular part. So instead of 2 pi RH, which was what it was for a cylinder, this one's going to be pi RL. And then in order to find the surface area, we have to take the side and add it to the area of that circle, and that area is pi r squared. So it's all right there. So lateral area, we want to make sure we have L, and we don't have L. So it tells us right here, when we're dealing with cones, that value is important. So we don't know what that value is, but that's okay because we see this right triangle that they've created here. And so we know that when you do a squared plus b squared equals c squared, and then this guy is your c squared, that you can find the other one. So you end up getting that this left side is 400. So when I square root and square root, I get L equals plus or minus 20, and that doesn't make sense for it to be negative, so this right here is 20. So when I'm finding the lateral area, it's going to be pi times the radius, which is what we're given, times the length of the slant height is what this is called. So when we're doing cones, it's the slant height. You're going to have to remember that, but you're not going to have to remember the formula. So you just have to remember that that's L, and that was worth 20. So then we get that this is 240 pi, and then there's centimeters squared. So 12 times 20 is 240, and then we have the pi, and the unit is centimeters squared. The next thing we have to do is find the surface area. So the way we're going to find the surface area is we're going to take the lateral area, and then we're going to add the area of the circle. So that's going to be pi times 12 squared, which is 144. So when I take 240 pi and 144 pi, I get 384 pi centimeters squared. Alright, moving on to the next one. This is also about a cone. It says leave your answers in terms of pi, which is what we did in the last one. Actually, I take that back. I need to go back up there because I didn't read my answers. It says round your answers to the nearest tenth. So I need to take this a step further, and I need to do 240 times pi in my calculator. So this is actually 753. Oh, that's a good one to round. I rounded that wrong. So I'm going to show it to you on the calculator. 243, or 240 pi. This 8 is going to make this a 0, but really what it's doing is taking that 39 and making it a 40. So we are going to make this 754.0 centimeters squared. And then this one, 384 times pi, is going to be a little bit easier to round. Oh, my pen doesn't want to write there. Alright, I did not see that. So this is in terms of pi, this is rounded. Okay, this is exact, this is approximate. Anytime you have to round, it's not the exact answer, it's the approximate. Find the lateral area and the surface area. So do we have the slant height, because that is L? Yes, we have the slant height. So for our lateral side, the formula is pi times r times L. So when I go to calculus, calculate this, I have pi, and then I have that L is 25, but I need to find the radius. So in order to find the radius, I'm going to use the triangle that they gave me, and I'm going to get r squared plus 20 squared equals 25 squared, because 25 is the hypotenuse. So r squared plus 400 equals 625. So r squared equals 225. So r equals plus or minus 15. So this is now 15. So I can go into the lateral one and do 15. So that's going to give me the cone shape at the bottom. So, and it says leave it in terms of pi. So that's going to be 375 centimeters squared. And they already put the pi right there, so I'm just transferring the number. Whoopsie, did you guys see I forgot the pi up here? Alright, the next one is surface area. So for the surface area, that's this guy right here. And the area of a circle is pi r squared, so I get the 375 from the lateral area. It's got a pi plus pi times 15 squared. 15 squared is 225. So 225 plus 375 is 600 pi centimeter squared. And again, the reason why I'm just putting 600 on the line instead of what I have up here is because there's a pi already up there. And the reason why I'm mentioning that is because I'm pretty sure my HRW does that too. So if you type in the pi, it's going to call you wrong if it already has the unit of pi there. Alright, I think we have one last one on the back side, so let's go ahead and take a look at this. This one right here looks like the clown hat. It's upside down. Yeah, party hat, not clown hat. So what we need to find the lateral area is we need pi times r times L. So we need this number right here. That's the L. And then we need the radius. And because this is a huge long line, this is telling us that the diameter is 12. So if the diameter equals 12, then the radius equals 6. So this right here is 6. So if I take that right triangle and just apply the Pythagorean theorem, I have 8 squared plus 6 squared equals L squared. Again, the hypotenuse, or C, is always the one across from the right angle. 64 plus 36 equals L squared. 100 equals L squared. L equals plus or minus 10. The negative doesn't make sense. So L is going to equal 10. So I have my lateral area is pi times the 6. Again, the diameter is 12. The radius is 6 times 10. So the lateral area is 60 pi inches squared. But it says round to the nearest tenth. So I'm going to do 60 times pi, and I get 188, and that 9 is going to round that up to a 5. So I get 188.5 inches squared. So that's the lateral area, and then for the surface area, I'm going to take that lateral area and add it to the area of the circle. So I get 188.5 plus pi r squared would be pi times 6 squared. So that's 36 pi. So 188.5 plus 36 pi equals 301.6. Now, I'm just going to take this back a second because I have a feeling my HRW is going to be tricky. So I'm going to change this. Instead of writing 188.5, I'm going to write 60 pi and keep everything consistent until I plug it in the calculator and see if it makes a difference. So I have 60 times the pi plus pi